So we go live, sir. We can start.
Hello, everybody. My name is Debashish Roy. I'm the Senior Network Trainer as well as the Cisco Network Specialist at the Indian Cyber Security Solutions. And these are my contact information for LinkedIn and Twitter, both my personal information and company information that is shared for your purpose. You can always contact using these informations. Today, we are going to discuss about CCNA, that is a very essential course for networking. The full form of CCNA is Cisco Certified Network Associate. Now, this associate level certification means Cisco has some levels of certification, and this is the foundation level of networking certification. But it offers a wide range of topics from LAN to WAN. It offers a very diversified topics offered by Cisco. This is a foundation level certification, and the current exam code is 200-301. Now, what are the benefits of doing this CCNA certification for networking? Now, I've already told you that right from the LAN, right from the OSI model, topology, IP addressing, right starting from that, it goes up to the WAN part, means the routing switching part. And it helps to build a proper knowledge or sound knowledge for the networking. And it will give you an edge for a networking career to build a strong networking career, a strong foundation for a networking career. Now, this is the entry-level certification for inter-networking. Now, what does that mean? Inter-networking means that you have two locations connected by some ISP. So two cities are connected by some third network, by ISP in between. That is inter-networking. And CCNA deals with that inter-networking, means it deals with the WAN technology. So anybody having the basic computer knowledge can pursue CCNA and should go for CCNA for doing career in networking, as it covers everything about networking. You just send a file from one PC to another. You just send a mail. That is the foundation of any networking, any LAN. You make a cable and you connect that cable to the switch. You connect that cable to the router. It may be a Wi-Fi router for any LAN access, or it may be a Cisco manageable router also for WAN access, or any non-manageable switches or manageable switches. Everything and anything is covered in CCNA. So it will definitely give you edge to enhance your career in networking if you do CCNA. I'll talk about the job opportunities after CCNA next. Now, the CCNA certified professionals work with routers and switches in enterprise networks, and they work in layer 3 level jobs, that is the L3 level jobs. As we know that there are 3 tiers, that is layer 1, that is desktop level job or desktop support, which deals with basic networking and hardware troubleshooting level. Then layer 2 or L2, that is the network administrator level or the system administrator, which deals with certain parts of networking and mainly on OS level troubleshooting. And layer 3 or L3 is there, that is dealing with routers and manageable switches. So if you do CCNA, after that, you'll have the job opportunities like as a network engineer, you can work in the L3 level in the routing switching configuration, as a network support technician or desktop support level, system engineer. All these opportunities are there for you after CCNA in big enterprises. So every enterprise networking, every company needs routers and switches to send data across the networks or to any other branches. So definitely you will have ample opportunities, ample job opportunities if you do CCNA. Now let's discuss some topics or some important topics that is coming in CCNA level. Now mainly it deals with the routers and the routing protocols, say there are many protocols, EIGRP, OSPF, BGP, many protocols are there. So how to connect a router to the PC, how to configure the router from a PC using CLI mode, how to configure the routing protocols, that will be the base of this CCNA. Then comes the security policies, that is very important. It is like the firewall, setting up a firewall or the access control list. So that is also very important for CCNA level. You can build access control list to restrict the network access from the outside network or from inside your network. You can also build access control list. It acts like a firewall. It is not a firewall, but it acts like a firewall technology. Now, Cisco next generation firewall is there, like ASF firewall. So the basic concept, theoretical concept is there for advanced firewalls. You have network address translation or NAT, that concept, the translation between private and public IP, that is there. IPv6, virtual LAN, there is VLAN that is created on the switch, that is there. Then you have some security topics as well, that is securing the switch port, that is switch port security from unauthorized access. Say, for example, some switch ports are not managed properly and some hacker has attacked that switch by plugging in the devices to the switch port. So you have to prevent that by configuring switch port security. Also, you can prevent attacking the DHCP server by using DHCP snooping. That is also a security method that you will learn in CCNA. IP version 6, quality of service, QoS, that is to control the router bandwidth controlling congestion avoidance, then wireless networking standards and security about the wireless networking. And last but not the least, automation. There is a configuring device with tips. Now, automation is a very big thing of today's network. It's a very new thing. So we are actually making scripts or programming in JSON language, JavaScript, or Python or YML language to actually configure the devices using programming or scripting instead of only giving commands. So this is automation that is there in CCNA. So this is an enterprise CCNA. So it is combining everything, not only routing and switching, but combining every aspect of networking that you will learn here. Now, what is the exam format? Definitely, that is an online exam for CCNA that you are going to sit for, and that is totally MCQ based. Exam code is 200301. Duration is 120 minutes, and the passing score now it is 82.5%. So that is the CCNA exam format. You only have one exam to pass to gain your CCNA certification. So that was about the CCNA and all its benefits. Now I'm going to talk about the routing. That is the main topic for CCNA, that is the foundation topic, that is routing that I'm going to talk about. Now, what is the routing? Routing, it is a process to send data from one network to another network. So if you are sending any data from one network to another, then in that case, you need a router, and that process is known as routing. If you are sending data from one city to the other city, so in that case, that process is known as routing. And definitely, it is performed between the two classes of networks or the subnetworks of the same class. So if you have a class A, class B, class C networks, or if you have two subnets of the same class, say 192.168.10.0 and 192.168.20.0, in that case also, you will perform routing. Now, what are the types of routing you will find? One is static routing, and the other is dynamic routing. Now, what is static routing after all? Now, static routing is the manual routing, and dynamic routing is the routing that is done by some routing protocols. So what is static routing? Static routing configures the entire path from source to destination network manually. Yes. So in case of static routing, if you have many destination networks, say 100 of destination networks, then you have to configure the 100 routes for the destination network manually. And it is faster than the dynamic routing, but it is time consuming and always tedious to maintain static routing if the destination networks are large in numbers. So if you have many destination networks, then it is difficult to maintain all those routes, all those destination networks. So it is definitely not possible to go for static routing if you have many destinations. If you have 1 or 2 destinations, 2 or 3 destinations, then definitely you should go for static routing. But the network destination address may change anytime. Say, for example, the destination address now is 20.0. It can change to 30.0 or 40.0 anytime. So it is not possible to go for static routing if the destination network is large in numbers. So in that case, you should go for dynamic routing. Now, there are some rules to configure static routing. So the serial ports of 2 routers, if you are configuring static routing between 2 routers, then the serial ports of 2 routers should be in the same subnet. That is very important. You cannot change the subnet, right? If the serial port of 1 router is in, say, 11.0.0 subnet, the other router should also be in the 11.0.0 network. You cannot just change the network from 11.0.0 to 12.0 on other router. That is very important. And the Ethernet networks on both networks, Ethernet networks will be in different networks. On both ports, the Ethernet networks will be different, because otherwise you will not require router anymore. If you have configured same Ethernet network, say 192.168.10.0 on both the routers, then you will never require routers. So it will be different in all the cities, or on 2 routers it will be different. Okay. Third is that default subnet mask to be used in case of static routing. That is very important. You cannot change the subnet mask. Means the class full routing should be used in case of static routing. Okay, and classless routing is not supported. You cannot change the subnet mask. So classless routing is never supported in case of static routing. Only you have to use default subnet mask. Another important thing is DCE and TTE. DCE means data communication equipment and TTE means data terminal equipment. Now, what is DCE? So you have a serial cable between 2 routers, and one end of the serial cable is connected to the ISP network and the other end is connected to the customer. So the end that is connected to the provider network, service provider network, that is known as DC, and DT means the data terminal equipment. Now that part of the serial cable is connected to the customer network. And there is a command known as clock rate that is to be used in the TCE part. So the cable that is connected to the service provider network, there on that route, on service provider router, you have to use the clock rate command. And we use clock rate 64,000 value. That will show you. Now, what is the static routing syntax after all? Now, if you want to make static routing, you should follow this syntax: IP space route, and then you have to give the destination network, and then the subnet mask of the destination, and the default gateway of the other router. Means the default gateway means the serial port IP address of the other router, or that we call that next hop IP address. So this is an example for static routing. So here are 2 routers, and you are configuring static routing, and you are giving this command IP route on this router, and on the other router there is a stub network, means it has only a single entry and exit point. So that is a stub network. You are giving that network address 172.16.1.0 and the subnet mask, and the default gateway that is 172.16.3.2. that is the default gateway. This is the process, that is the general process. Otherwise, you can give, there's a second one you can follow: IP route and the destination network, destination subnet mask, and the interface, serial interface attached to your router. That can also be done. But mainly the first process is followed. So after that, we'll talk about the default routing. But before going for default routing, that is also part of the static routing, I would like to show you how to configure the static routing using Cisco Packet Tracer. So you go to Packet Tracer and you take any two routers. You take two PT routers and this is a serial interface, and this is DC, this is DT. You connect the serial to the serial. You take two laptops and connect it to routers. And you give the IP address. And 001. You give clock rate command on serial interface. Clock rate 64,000. Now there are many clock rates available, but you have to give 64,000 because generally the routers that we use for CCNA, they are actually compatible with clock rate 64,000. You can definitely go for clock rate, this type of clock rate. These are the ranges, but we generally use 64,000 for DC, right? Now you give the IP address to the serial interface. First you give no shut, but the serial interface will be down because it will be only up when the other end is up. Okay. Yes. Now on the other router, you configure similarly the IP addresses. Say in this router Ethernet port, you have 20001 as an IP address. You go to serial port and give the IP address as 11002. Now you go to the PC IP configuration and give IP address as say 10002 because I must, and gateway as 10001. And 20002 and gateway is 20001. Now I will configure the static route to send packet from this laptop to this laptop. So here you go to config mode, you exit IP space route, and then the destination network, that is 20.0.0.0 and subnet mask 255.0.0.0. 1 minute. And the default gateway, that is 11.0.0.2. That is the serial interface of the other router. Go to router 1, you exit. Route 10.0.0.0 and serial interface IP 11.0.0.1. Now the serial interfaces are configured, Ethernet interfaces are configured, and also static route is configured. Now just see the route by giving show IP route. Yes, you can see the static route. See, these are directly connected 11 and 20. There is a serial and Ethernet, and this is static 10.0.0.0 via 11.0.0.1. This is the AD value, that is 1. Okay. Now you go to router 0. You show IP route, and you can do the static route. It's 20.0.0. Can you ping the two pieces? Ping 20.0.0.2. One will be timed out because of ARP, and then you'll get the reply. And on from other PC, let's laptop 1. Can you ping? Yes, you can. And if you go to the simulation mode and you just click on this, add simple preview, click on here, click on here. A minute. Yes, you can see the packet is traveling between the routers. So this way, the entire communication path you can see in this simulation. Okay, is coming. So everything is based of simulation. So the stack is very clear to us. Now, let's go to the default routing or the default static. Now, default routing is performed to save bandwidth of router serial. Say, for example, we have different destination networks. Many destination networks connected of the destination router. There are different Ethernet networks connected to the destination router. And say, for example, there are 10 Ethernet interfaces. So we have to build 10 static routes for that. But if you build that much static route, then the bandwidth, serial port bandwidth will be consumed more. To avoid that much bandwidth consumption, we can use default routing or default static route. So you will make only one static route, and you will actually route data to all the Ethernet networks. Now, it is generally performed between different branches of the same company. So if a company has different branches in different cities, different locations, or the different locations in the same cities, then it goes for the default routing or the default static route. It is not performed between different companies generally. Now, what is the syntax? Syntax is IP route 0000 and 0000 and exit interface. It means that, say, static default route command, first 00, it means the destination network, any destination network, and any destination network subnet mask. So the router doesn't care which is the destination network. It will send packet to any destination network, and the destination network can have any subnet mask associated with it. And the router will go through router B through the next hop. That is the interface connected to it, generally the serial interface. That is the exit interface. So this is the default routing, and before proceeding to any other dynamic routing, we can see this default routing as an example in packet design. So here you just remove the current static routes, because static route and default route, default static route will not work together. No IP route. And as you have removed, you configure the default routing here by IP route 0.0.0.0, 0.0.0.0, and x2 by 0, that is the serial interface that is attached to this router, the exit interface. Go to router 1, also remove the static route. and interface also is 2 by 0. That is its own serial interface, not the other router, but own serial interface. Gives you IP route, and you can view the default study route there. This is the default study route, and start means it's a candidate default route, and it has a CID of /0 also. And can you go to router 0 and verify? Yes, you can see the default route. Can you ping or go to the laptop command prompt? Yes, you can. So actually, this is actually a static route, but this is known as default static. So this is default routing. And now let's come to dynamic routing. So we have covered the static routing part and now dynamic routing. So dynamic routing is done by some routing protocols. Now I've already told you that there are some routing protocols to be configured for dynamic routing like EIGRP, Enhanced Interior Gateway Routing Protocol, Ospf, Open Shortest Path First, BGP, Border Gateway Protocol. These dynamic routing protocols we configure. And in this case, you have to only configure the source network. You do not need to configure the destination networks. And the routing protocol calculates the best path to send the packets based on the routing metrics. So there are some routing metrics, say, for example, bandwidth in case of Ospf. So it configures the routing according to the routing metrics. So this is the advantage of the dynamic routing protocol, that in case of dynamic routing protocol, you do not need to actually configure the source and the destination network both. You do not need to bother about the destination network. Even if the destination network changes, you do not need to configure that manually. The dynamic routing protocol itself does that. Now, there is a factor known as AD value, that is the administrative distance, that we need to discuss. Now, say, for example, on a router, previously, static routing was configured, and now somebody has configured the dynamic routing protocol, such as Ospf or like that, any protocol. Now the question comes that will the static routing work because it was configured before, or now will the dynamic routing work? Now, in that case, Cisco has specified some specific values for static routing and also for some dynamic routing protocols. AD value specifies reliability of a route, trustworthiness of a route, and lower AD values are always more preferable. So if you have lower AD values for any protocol or any static routing, that will be preferred over others. Now we'll discuss some AD values. Before that, that is a range of AD value. It starts from 0 and ends to 255. 0 is most trusted route for AD, and 255 is unreachable. If any route has an AD value of 255, then the packet will not be sent through that route. These are the AD values. Some AD values like directly connect interfaces means the local interfaces of the router has AD value of 0. Static route or static routing has AD value of 1. And sometimes it is known as static routing has AD value of 0 and 1 because 0 is also included within the static route. Anyhow, and then comes all the dynamic routing protocols like internal BGP. Internal BGP has AD value of 90, that is inside the same autonomous system. And if it is external BGP, you are inserting external BGP routes to some AS, then the AD value is 20. Similarly, in case of EIGRP, if you are configuring EIGRP inside an X, that is internal with EIGRP, the AD value is 90. And if you are configuring it between some AS or you are injecting routes in some other ASs, then external EIGRP has AD value of 170. Say, for example, you are injecting EIGRP routes into Ospf or BGP, then the AD value goes 170. And Ospf has AD value of 110. So These are some AD values to be remembered. And if you have configured, say, any dynamic routing protocol with static root, then definitely static root will win and it will work because 1 is lower than any AD value of any dynamic routing protocol. And in case of dynamic routing protocol, say for example, if you have configured Ospf with EIGRP, then EIGRP will win because it is having lower AD value. So the lower AD value will eventually win and eventually work. Now with those knowledge, we can discuss briefly about one dynamic routing protocol, that is Ospf. Open shortest path first. And Ospf is a link state routing protocol. Now what does that mean? Now routers use link state advertisement or LSA packets to exchange routing updates. Now every router has this routing table, and in its routing table it has some informations. Now it has to exchange those informations with other routers, but in that case, in case of Ospf, it uses LSA, link state advertisement package, so that every router exchanges LSA information with each other. It is not performed in serial manner, means it is not done in that way that router 1 will exchange to router 2 and router 2 will exchange to router 3. No, it will not be done that way. Every router will actually exchange the LSA information between themselves. So the routing table is updated very fast. So that's why the Ospf converges very fast. Okay. Then another feature is that Ospf is vendor independent. So on any router, be it Cisco router, be it Juniper router, you can configure Ospf. But previously, the other protocols like RIP, Routing Information Protocol, that is now not relevant, but EIGRP, that is Cisco proprietary protocol, now you could configure the protocols only on Cisco routers. But Ospf, by default, is a vendor neutral. And it supports classless routing. That is very important. That in case of RIP, by default, it was classful. EIGRP, by default, it was classful. Although you could use it as classless, but by default is classful. But Ospf by default is classless. It supports subnetting, it supports VLSN. Now, that is the Ospf hierarchical design that you have. You have the backbone network, that is the area 0, the backbone, and you have certain areas as area 1, area 2 under the backbone areas. So area 0, the backbone area, actually controls all the Ospf operation, and under that there are many areas. So area can be up to 65,535, and 2 areas are connected by the backbone area. So backbone area, through the backbone area, the LSA state information is exchanged between the areas. So this is the Ospf hierarchical design, or the hierarchical design topology. For that, also Ospf synchronization or routing table updation is done very quickly. And also the LSAs are limited inside particular areas. So that is the design of the Ospf. And also, if any router is facing any network instability, that is confined in a particular area. Say, for example, in area 1, some routers have some issues, some interfaces down. Now, that will not be spread into area 2. Now, there are two things: autonomous system and area. So autonomous system is a logical entity, is a bigger entity, which is a big entity, and routers are not put in the autonomous system only, they are put in areas. So autonomous system, you can say it's like a domain, or you can say it is like a work group also. So we create work groups in case of OSS, and we give some names of the work groups. So it is like autonomous system. But the autonomous system is divided into further areas, means smaller entities, to actually limit the LSA updates, LSA broadcast, that we say LSA flooding, because I have already told you that routers actually send and receive LSA with each other. frequently. So to limit the broadcast, we create different areas to limit the broadcast. Okay, so this AS is divided into different areas, and routers inside an area is called neighbor routers. So the routers that reside in a particular AS, they are called neighbor routers, and they exchange LSS. So only neighbor routers exchange the LSA updates. Now, what are the rules for becoming neighbor routers? Now, neighbor routers, who will be the neighbor routers? If there are hundreds of routers, then every router will be neighbor router. No, neighbor routers should be those routers which belong to the same area. So in that previous example, the routers which belong to area 1 are neighbor routers for area 1, and just like that. Now, there are two terms, hello and dead timer, two timers that should also match. Now, what is the hello timer and dead timer? Routers actually send and receive their status updates, means updates of their interfaces by hello protocol. It is not routing update, it is their status update. And in broadcast and non-broadcast NBMA networks in Ospf, we find that hello timer is 10 seconds by default and dead timer is 40 seconds by default. What is the dead timer? If, say, for example, one router 1 is sending hello to router 2, but router 2 is not responding. Now, will router 1 assume that the router 2 is dead? No. It will wait for 40 seconds. It will send 4 hellos. Even after that, router 2 doesn't respond. Then router will assume that router 2 is dead. So that hello and dead time, if you change any router's hello at dead time and inside an area, then the router adjacency will fail and the Ospf route will not be shown. So those timers should be identical between all the routers inside an area. Now, with those knowledge, we can configure the single area Ospf. But before that, we need to understand one more thing, that is wildcard mask. Ospf or any other dynamic routing protocol does not use subnet mask like classical routing in case of static routes. They do not use subnet mask. But there should be some mechanism to identify the networks. So in that case, wildcard mask is used to identify the networks. And means there should be some mechanism to send routing updates from one network. For that, the identification of network wildcard mask to be used. And wildcard mask, you can say, it is an inverse subnet mask for the opposite subnet mask, opposite of the subnet mask. How it is calculated? It is calculated by subtracting subnet mask from broadcast address. So the broadcast address we know 255, 255, 255, 255, 4 255s. And for example, if your subnet mask is 255.000, and if you subtract it, the wildcard mask will be 0.255, 255, and 255. Okay. So that is the wildcard mask that we'll use. And now we can configure the Ospf singular Ospf before moving on to this next topic, that is designated router. That is also an important feature of Ospf. So let's first configure the Ospf in packet tracer. You take two routers. Again, you connect it through serial cable. You take two pieces. First, you have to again give the IP address. Say 10.0.0.0 and subnet mask 255.0.0.0. Sorry, 10.0.0.1. serial clock rate, same way. (11,001). And first give the IP address to the other router, and then we'll configure the Ospf. Okay. (20,001). (11,002). Now I can configure Ospf on this router first. Exit router Ospf, and you need to give a process ID. Yes. Now what is the process ID all about? Is this area ID? No, it is only a Ospf process ID that is significant to the local router. You can give any process ID, and two routers can be in different process. So on two routers, you can give one router process ID 1 and the other router process ID 2. Same or different, anything will happen. Say I'm giving router Ospf 1. Network, say first 20.0.0.0, and you give the wildcard mask as say 0.255, 255, 255, and you have to connect it to the backbone area, that is area 0. And the other network, that is the serial network, that you have to add 11,000, and also the wildcard mask would be 0.255, 255, 255, and you have to connect it to area 0. Now on router 0, the same thing you have to do. A router Ospf and process ID you give 2. You can give any process ID. What? Say 10,000. Wildcard mask 0.255, 255, 255, and area 0, and also 11,000, the serial network. That is the configuration, you can say, of the Ospf. And see, the message has come, confirmation that the 20,001 neighbor has been discovered by the Ospf from the Ospf process ID 2. Now you just see the Ospf root by show IP root. Yes, you can view the Ospf root 20,000 connected by 11,002. And what is this 110? This is the AD value that I have already told you. And 65 is the cost. Ospf uses the bandwidth to determine the best path that I've told you. This is a cost value. And go to router 1. Show IP root. And here you can see the Ospf path. So eventually the PCs will also ping because PCs have default gateway configured. So this way the Ospf can be configured. This is a single area Ospf that you have in case of Ccna that I've shown you how to configure. Next topic that is very important for Ccna aspect or Ospf aspect, that is designated router, DR, and backup designated router, that is BDR. So what is DR and what is BDR and why they are used? See, inside an area, number of adjacencies or LSA adjacencies, that I should say, to be minimized, to minimize routing updates, LSA flooding. So every router, they send and receive LSA to each other, and for that reason the adjacencies are built. DR and BDR is used to minimize the router adjacencies. Now what is the formula to calculate the adjacency? It is n into n minus 1 by 2. N means device or the routers. Now if you have 4 routers, you assume there are 4 routers in a network, so it would come as 4 into 4 minus 1 by 2. 4 minus 1 means 3. So 4 into 3, that is 12 by 2, means 6 adjacencies will be created. And if you increase more routers, then more adjacencies will be created for LSA update. So it will create a LSA flooding or the LSA broadcast. So you cannot allow all the routers to communicate with themselves by LSA. there will be DR and BDR. DR will be like captain or leader, and BDR will be vice captain. So the process should be there that the neighbor routers will communicate only to DR and BDR, not within themselves. So neighbors that are known as DR other, they send the LS update to DR, and if the DR is down to the BDR using a specific address, multicast address, that is 224.0.0.6. So neighbors will not exchange LS updates within themselves. They will send the LS update to DR, or if the DR is down, in that case only BDR using 224.0.0.6 multicast address. Now, for in that case, the LSA total LSA update will be minimized. Now, if DR or BDR wants to disseminate to other neighbors, then it will be using address to 224.0.0.5. These are the fixed multicast address for communication between DR, BDR, and DR other means neighborhoods. Neighbors do not send LSA between themselves. That is the bottom line. That neighbors will not send LSA updates between themselves, and they will minimize adjacencies. So this part also we can see in Cisco Packet Tracer how to configure DR BDR. In this case, remember DR BDR is only elected according to the Ethernet interface. So we have to take a switch. Take a switch and take two routers. Connect to straight cable. Just give the Ethernet port IP address. Remember that through serial port, no DR BDR is elected. I am giving the IP address as 10.0.0.1, and I'm adding it to a process. And set this. And this router give IP address as 10.0.0.2. So this should be the DR, because DR is having the router which has the highest IP address. Have this and just reload both the routers. If you reload the router, then only DR or B direction will take place, and the highest IP address of the router, that will be the DR. So 10.0.0.2 will be DR and 10.0.0.1 will be BDR. Let the OSP process start. Okay, for some reason the Ospf configuration wasn't saved in the second router. So let's do it again. Router Ospf 1. And this time we have to add 10002. And also serial IP address was not saved. 1 minute. So I have to configure serial port again. The internet port, Ethernet IP address is not there. Thing. So N002 and also with router SPF, say anything, say 3 or I think Ethernet interface is up. Router SPF 1. And network 10.0.0.0. Let's verify show start. And this time you can see that the router adjacency has started. Router SPF. Now let's reload it again. And on router 1 also to reload that. The OSPF process now will start. Definitely it should start now. Yes, we have started now. Now give show IP OSPF interface. Now see the designated router, it is showing you as 10.0.0.2. I've already told you that the highest physical IP address will be designated router and the backup designated router, the BDR should be 10.0.0.1. Now, sometimes it had happened in Cisco packet design environment because it's a simulator, it shows you different. So in that case, you just reload the routers once more, and then you will see the designated router and packet designated router ID correctly. Now, this is about DR and BDR, but the problem is that DR and BDR in this case is elected according to the Ethernet interface. Now, that is a physical interface. Now, any physical interface many times go down. Now, say for example, the Ethernet interface of my router has failed. Now, what will happen? The DR-BDR will also fail. The state will be unstable. So, in that case, what you will do? You will do the DR-BDR selection according to serial port. No, you cannot do that. So, there is a logical interface for electing DR-BDR that we call as Loopback Interface. So, that is next that we need to discuss. So that is Loopback Interface. Now, what is that? It is a logical interface for the Ospf process. And why is it used? Because I've already told you that the physical interface can always go down. So it is not reliable, or it is not advisable to actually configure DRBDR entirely on physical interface. So you can have physical interface, but you should configure loopback interface also. And loopback interface has priority over physical interface in DRB direction. Yes. So if you have configured loopback interface on the router, then the router will only see the loopback interface. So the Ospf process will start according to the loopback interface, and also DRBDR will also be elected according to the loopback interface. Okay. And loopback interface never goes down because it is a logical interface. You do not need to give no shut even because it's always up. So it will never go down, and your DRBDR state will never be unstable. So you should configure loopback interface. How to do that? Let's see. So on these routers that we have configured the physical fast Ethernet port, you can configure loopback also. You go to any router and you configure interface loopback. And what is the range of loopback? Is a huge from this much. You can configure the loopback interface on a router. So you just configure loopback 0. See, as soon as you hit the enter, the line protocol is up. So the data link layer is up on the loopback interface. So you do not need to go for any no shut command. You just give the IP address, say this time 20001. And you add this to the router Ospf process. So what is the router Ospf process? How can you verify the router Ospf process? Now you just give show start. So you have to view the process ID, right? The router Ospf 1 only. And give the network as 20.0.0.0 Wildcard Mask and area 0. Control Z and save this. Copy and start. Go to router 1. That is loopback 0. And configure the IP address. This time as say 20.0.0.2 because this will be the DR. And check out the startup configuration for the router process ID, that is also 1. And add it to the router Ospf. And set this. After doing this, just verify that it's there. The back interface is there, and also router Ospf is there, and also verify it on router 0. Yes, you have added loopback, and you have added to the Ospf process. Now reload both the routers and see what happens. Let the Ospf process start. See, the Ospf process started by using which ID? 20001. Previously, it was started by using 10001. Why is it taken out 20001? Because 20001 is a loopback interface. Now, I have already told you that if you configure loopback interface, it will be the highest priority. And you check the DRBDR status also, like show IP Ospf interface, and you can see. Okay, so I have already told you that in simulator sometimes it happens. Now it is showing you designated router as 20001 and backup designated router more than that, so we have to reload it once more. Reload both the routers again. Done. Let the Ospf process begin. Yes, and now give show IP Ospf interface. Now see, designated router is showing correctly as 20.0.0.2 and backup designated router is 20.0.0.1. So it proves that if the loopback interface, the logical interface is configured, then it has the highest priority. So it has more priority than the physical interface. So this is the physical interface 10.0.0.2 and 10.0.0.1, but router is not caring for that. It is Ospf is taking the loopback interface as the DR and the BTR. So you go to router 1 also, and you can verify from there also. Also designated router 20.0.0.2 and backup designated 20.0.0.1. So that is the thing that I've shown you how to configure DRB and BTR. And then I'm going to share you lastly some LSA types of the Ospf. So Ospf, we already know that uses LSA to actually share the routing updates, to disseminate routing updates to other routers. But there are some LSA types that are important for Ccna purposes. One is LSA1. So actually there are 11 types of LSA and 9 types of LSAs are actually used. But in case of Ccna, we do not need to know all these types of LSA, but at least these LSAs, these top 5 LSAs, we need to be familiar with. LSA1 is the router LSA. Router LSA means every router has its own IP address of the serial port, Ethernet port, and it advertises those IP addresses of its own network. So that is the LSA1 that is advertised inside an area. LSA2 is used to reach DR or BDR. So the DR or BDR has an address, IP address, and of its Ethernet port, and that IP address is advertised by LSA2. So that is used to reach or to locate the DR BDR by the neighbor routers. Now LSA3, that is network summary LSA or inter-area LSA, that is used for inter-area communication. So in case of Ccna, we do not have the multi-area Ospf, but if you have multi-area Ospf configured, say more than 2 or 3 areas, then you will have the inter-area communication, and for that inter-area communication, network communication, you have the LSA3. LSA4, that is used to reach the ASBR, autonomous system boundary router. So if you're actually injecting the external route to the Ospf from the EIGRP AS or the BGP AS, and there is an AS boundary, autonomous system boundary. In the boundary, you have ASBR, which connects different ASs together. Then in that case, to reach the ASBR, to actually reach the routes, to inject the route, you have the LSA4. LSA5 is external LSA. It is used to inject external routes in Ospf. So actually, the external route means for many BGP protocol, EIGRP protocol. Also, it can be injected into the Ospf system, Ospf LSA, and for that external systems, you have this LSA 5 or the external LSA. So these are the LSS that is very important that you have to remember for the Ccna partners. So I have discussed the main topics, the main points of the routing today, about the static routing, the default routing, the two types of routing that we have, and also the dynamic routing protocols that only you have Ospf in case of Ccna purpose, the networking purpose that is very important and that is very relevant to our networking purpose that I have described the main topics for the Ospf. And also I have shown you in Cisco Packet Reserve all the practicals for configuring right from the static routing, then the default static route, and also the Ospf. So these are the topics that I've discussed with you for today about the routing class. I hope it was informative for you, and I hope you have gathered a lot of information from this and you have enjoyed this class. And if you have enjoyed this class, and if you want more like these classes, then you please like and subscribe our channel on YouTube. So that's it for today, the Ccna class, and we'll join some other day with the class. Okay, so thanks for attending this session. Thank you for that. And that's it. Thank you. Yes, over to you, Patrick.
Thank you, sir. We'll close the session. Thank you for your time for the webinar. I hope the webinar was quite informative for our students. Do follow us and subscribe to our YouTube channel at IndianCybersecuritySolutions.com as well as on our Facebook page. We hope to see you next time, sir. Thank you, everybody.
Thank you.